All right, so what is this? This is a goal to describe in a language, which this is a not exact Go. Describe the libp2p interfaces as succinctly as possible, and to try and get like some structure that we can then use to potentially compile into think of it kind of like protobuf or gRPC, where you would have an interface definition language that you would write an interface in, and then you could use certain kind of code gen tools to do something with that, like generate stub implementations or generate RPC things or interoperability tests, or at least checking that something is using, that some other languages actually has API coverage. That's kind of the goal of this effort. As well as just standardizing things, because right now a lot of this stuff is in documents, which is less successful than if we had like a test case that could like test whether or not like the thing is, everyone's converged. So I'm just gonna go through these and just kind of get your take. These are a draft, but it gets kind of, these seem kind of obvious, but it gets a little bit funkier underneath. So at the very top we have here, at least in as how GitHub just decided to present it, because it's not how I would necessarily introduce it. We have libp2p.peer discovery, and so this was an interface that just has discover peers, a single function that emits an array of peer infos. And so the idea is that a peer discovery protocol is just that. It just gives you that one single function and just emits a set of peers every once in a while. Content discovery is very similar. It just emits a set of CIDs. Now, you might say, hey, like that just smuggled a CID. What? That's from IPLD. Like, what is that doing there? Maybe that should be there. Maybe that shouldn't be there. There's a peer routing is where we actually start thinking about finding specific peers. So having a function where we call find peer, we give it a peer ID, and we get back a specific peer info for that peer. Then content router would be, we try to do the same thing for content. We put a CID and we get back a set of peer infos that might have that content. So far so good, right? Like anything, anybody see this is like totally new? No, great, that's awesome. So here's where it starts to get a little bit interesting. So David and I talked a lot about this idea of a record store a long time ago, and this is where like this IPRS nonsense came out of, and so on. But the basic idea there was to say, like, look, things like DHCs and things like DNS and things like PubSub all use the same kind of primitive, which is a little bit of information that has usually some kind of cryptographic checking and some kind of conditions for validity. And everyone kind of reinvents this every once in a while. And every system has different versions of this. So it might be a useful idea to kind of synthesize that and to just have one very simple way of describing what a record is and like the cryptographic operations you might do on the record, like signing it, like including a proof of something, like, hey, you claim you have some file, maybe include a proof of that. And then the validity stuff around, like, maybe it has an expiry and you have to check that that's correct according to, maybe it has a TTL, maybe it has an expiry based on some notion of time, like NTP, or maybe it has an expiry based on some stronger notion of time, like a blockchain. And so the idea is like, okay, well, if we started then creating things like DHCs and PubSub to work over that, that kind of record store, then we could probably duplicate a lot. So far, that's an idea. That's an idea that like lives on like some issues. And I think maybe David implemented some of this stuff, but that's kind of as far as I got, because that's how we got to a lot of the IPLD work, because then we started thinking, oh, what if we start structuring this? It's when we tried to structure these records into and put them into IPFS that we said, wow, like, it really sucks that you don't have structured data in IPFS, and you have these files, and you don't have the ability to just put in something like JSON or CBOR and deal with it like really nicely. And that's when we started exploring all that world, and then we got lost there for a while, and we're finally just coming back. So it remains to be seen how much of that we'll use. But the reason I bring it up is because once you have a record store, you can kind of do a lot of things with it. You can basically build a content router, a peer discovery and content discovery over any record store. Now, that might not be a great idea, depending on the semantics of your record store. But the idea is that, like, if push comes to shove, you could use that. And so what does this mean? Well, a DHT could be a record store, and that has certain scaling properties, as we've seen. And so it works for some things well, and it works less well for others. A blockchain is also a record store, and that has completely different performance guarantees. It is, kind of permanent, so your resolution will probably work fine. But publishing will be extremely slow, like way slower than the current DHT. But it may be censorship resistant, right? So you start getting these different properties falling out of it. And there might be reasons why you might want this kind of abstraction. So anyway, that's all I will say on the record store. Then we start thinking about like DHTs, and really what a DHT so far is, it just kind of fulfills these different ways of these different interfaces, peer discovery, peer routing, and so on. That's something like Kademlia gives you those things. We've talked about that before. Here's PubSub. This is like a different attempt at the consensus one. I don't necessarily like this one. Then it is pretty clear that libp2p has to have crypto in it. It has to define a whole crypto module in it. You can't really define things like peer IDs without injecting the notion of public keys. And then once you're there, you have to include private keys and public keys and hashes. And then also if you have records and signing and so on, you're in crypto there as well. So it's pretty clear that whatever the core interfaces of libp2p are, they have to include some set of abstractions around crypto. Fun side note, this file, the history of this file was that it got generated. I was sitting down with Tim Berners-Lee explaining what libp2p was, because it's really big and confusing. And I was like, okay, well, let's like walk through the interfaces. And then that's how the beginning of this file started. So it's kind of funny. One of the things that I got to here was that potentially it might make sense for, and we saw this before, should CIDs should IPLD actually, instead of being seen on top of libp2p, actually be a building component? That feels like it leaks too much, like you would want to pull in a multi-hash, but there might be reasons for doing this. Then where a lot of the complexity of libp2p lives is in the networking stuff, and I kind of want to just hide that. I want to almost separate all of the networking pieces, like the normal connectivity networking, not like the DHT networking. Things like connections, endpoints, encrypted connections, muxers, streams, dialers, listeners, and also transports and all that kind of stuff. And just kind of put that into a side. That's just a whole bundle of stuff that's all related to connections and maybe should be kind of separated out a bit. And then I want to get rid of the host abstraction that's in Go IPFS, in Go libp2p. And I want to replace it with just calling it a node, as JavaScript does, because I think that's a way better idea. The host concept was bad. What's that? Yeah, yeah. Do you have a better idea? Cool. But it seems like, does a libp2p node need to be any bigger than this? Oh, changing swarm for switch. That's another nonsense. That's right. That's right. Almost. You probably do want disconnect. That's right. Yeah, I kind of split that out here. Yeah, so here's the peer ID and peer info stuff. Transports error peer. Here. That's right. Transports would be like shoved into the switch. Yeah, I kind of want all the connectivity messy stuff should like be bundled in there, kind of like under a rug. And like if you want to peek in there, totally welcome to. But otherwise, you shouldn't have to. This is to go idiomatic. This is like useless here. Yeah, this is also not worth considering. Anyway, this is a draft of like trying to distill the interfaces down to something like much more understandable. I don't know, quick feedback. Is this a good thing to pursue? Do you feel like this is a good thing to pursue? Yes? Cool. All right, we'll keep bike shedding this. With that, I'll hand it off to David. Any questions on this? Yep.
I just want to say, I think this is a good thing to pursue. I think this is a good thing to pursue, and in a similar vein to what I'm trying to do with the docs for IPFS as a whole, like I think there's a lot of room in libp2p whenever we get some more organized docs for a similar set of like concepts, and I think those map really closely in a lot of ways to what you're trying to do here. So
yep.
There's a good concordance, and these things can all go together.
Sounds great. Thank you. Any other thoughts, comments, questions?
Working on going through IPRS yesterday with B5, and the one thing that we sort of came across was that there's the validation schemes, and then there's the ordering, and we sort of ended up settling on calling them like selection schemes as a way of figuring out what record should be chosen of a set of valid ones. And that was the only one where we were like, that probably needs to be in the spec for it.
Yeah, so this would be like an additional function. The idea of ordering is that it should always be possible to pick the best record.
Yeah.
You should have one best record. And then I guess selection is, you mean you might have you might have many records that are valid, and you might have multiple purposes for a record?
More like you take that top one as your best record, but the rest are still valid.
Yeah.
So
yeah, that makes sense.
It includes the ordering.
That's right.
Yeah.
That's right. Yep. So and you know, a lot of that IPRS thing is pretty raw. Like it was kind of like ideated and then kind of abandoned for a while as we launched into Enter the Merkle Forest and got lost there for like years. But there's something promising here that is kind of appealing, and so we should keep massaging this until we find something that's good. One of the things that also kind of gets lumped into this is that, and this is why IPLD matters here. What you can do if the records are IPLD nodes is that you can link to code in an authenticated way. So you can have a record linking to the code that validates it. And that might include all of the code that checks signatures, that checks proofs, and all that kind of stuff. So you could have, if a record is an IPLD object and it represents a tree of things, then you could self-describe the entire thing. You could self-describe everything you need to get to make sure that this thing is correct. And the reason why that's useful is that when somebody comes along and builds a new kind of DHT or a new system like IPFS and invents new records like providers and so on, it would be great if that could have a very easy onboarding path into the rest of the network without meaning that suddenly everyone has to like deal with this weird new thing. And it should be possible to kind of contribute that new type of thing to a growing library of records in the system. Think of it also in terms of DNS. So DNS has a bunch of random records with weird types and weird, like, the tons of systems don't implement or don't support because they implemented just the basic ones. And now there's all these other types that just don't work with a bunch of the tooling. And it would be really nice to have like a way of smoothly upgrading all of that, so that all of those tools could just say, oh yeah, this record is pointing to code that is signed by certain such and such authorities. So we're totally willing to adopt this whole new record type without even having to change the code at all. So that's where that's why kind of IPLD gets smuggled in through here. But then that's annoying because it then like bubbles it all the way up into libp2p, which is frustrating with interfaces. Any other questions, or I'll turn it over to David. All right, sweet. Thanks.